statistics. So, we did not talk too much about data mining, data analysis here, but data is something perhaps you can motivate the program directors from NSF or interested in this.
The data mining people involved on this list.
I've been talking to, I guess, some of the organizers in private and both to the UN and to Rich Scott Mark and so on, and to others. And so this has helped me crystallize ideas a little bit. So let me try to be a little bit practical, because I'm not planning to do any more directing or administering in this life. I really want to do my research, and I truly enjoy not having to wait until 5 or 6 in the afternoon to do what I like. But out of 22 years of getting various things on both sides of the Atlantic, I think, and the Nazi service and so on, I've added a few things. So, on the practical side, let's say that Dave told me that the IMA gets about $2 million from NSF and about $1 million from private donors and something from the university. And from somebody else, I forget who it was, I heard that the CNG program was something like $12 million per year. And I was actually fairly surprised to hear him say, oh, he had never heard that it's supposed to come to an end. He only heard it here. But, it's probably a little bit too modest. So I think that to satisfy everybody involved, and that means program managers in Washington on both the math and the geo side, and of course the communities that for whom this is important and the really supposed to happen. It would be good if we could preserve as much as possible of those $12 million, in the face of whatever budgetary vagaries this current country and its research are going to undergo. And it would be also good to preserve as much of that as possible for what we really care about, which is then our own personal research and our postdocs and grad students. Okay? I mean, the NSF was originally created for the single investigator, facing 1 or 2 students or postdocs or whatever. And of course, over the last decades, it's become more and more important to show big enterprise. So, we can't escape that entirely, but let's try to escape it as much as we can. And another aspect of this is that, there was something about talking to Congress people mentioned. If you only have Congress people from Illinois, this is not going to work very well. I mean, we know that from the superconductor, super collider, or whatever that was called, for which there was very huge enthusiasm in Congress until it was decided where to put it. So I really think that the people who had this idea and worked on this meeting and so on, and they did a great job. And I think it is important to have some sort of activity in order to both have cohesion and take this to a new level of integration and whatever. But we need to also spread it around the world. And so, if we are talking, let's just say, to be reasonably much pessimistic, but not too pessimistic, where it will lose about half the money, it's going to go from 12 million to 6 million. Let's say that 2 million goes to Chicago, and the rest goes to other things. Okay, and we can talk a little bit about what those other things should be. I think that they could still be individual grants, but with some sort of obligation of paying out the dues in some schools and visits, exchanging of students and so on. I've also talked with Peter Gatworth with Monster Fuentes about this network, and there's another one with Chris Jones, a company we have in the Math of Climate, the statisticians just started last Saturday, and it has a slight disadvantage, namely that you need to have money already for your postdoc and only extend the postdoc by a year, or maybe send her or him somewhere else, rather than having a full postdoc. So I think that to really make this satisfactory, we have to think along lines like these. You know, I'm not particularly so far fixed in really clear proposition, but I really want to submit it to this group of people that we should think somewhere along these lines. You know, we can have a combination of an institute like the necessary IMA, ICANN, whatever, that would be GeoMath or Math-Geo or whatever in whichever order, and that would be the Chicago area, maybe at the University of Chicago, and some other activities that would involve both, obviously, you see, also, you have to remember all the people that this money, as resources are getting scarcer, and I see this in Europe, the knives are getting longer. I also know that from sitting on various NRC committees, and consulting committees to NCAR and so on. You can't tell the community that you're going to take money for whatever period of time away from individual grants and have them happen. So, some of the money that is going to have to be competed in the same way that the CMG grants have been competed. And again, with this additional constraint or benefit of contributing to the joint enterprise. So, well, I think I've talked for a long.
So, what you said suggested to me that maybe something we could say to be a little bit specific, other than just keep money for PIs, is money for postdocs, which is, other than the general math sciences postdoc, it's kind of hard to come by postdoc money in the mathematical sciences. But if you had a program that said, for example, postdocs had to have a joint mentor from the mathematical side and the geo side, that might sound like, oh, okay, that's slightly new. And then where you had like some annual conference where all those postdocs and their mentors got together, that this would be a way of trying to encourage this kind of interdisciplinary training. And sounds new enough that you could sell it, but still support something that we would all want to support anyways.
Absolutely. Absolutely. I don't have any profound wisdom, but a couple of thoughts might help. It seems pretty clear that what Jinping and his colleagues would like from us is some document that they can use to try to promote the continuation of CMG-type activities. And that the Geo basically has, or and to be precise, the AR, has basically dug in their heels to say, we don't want to continue that. That they're not going to back down on, but on the other hand, if we give them a fairly strong case that they can use within NSF to say we want the continuation of these activities. I think someone last night, it was Doug, made the profound observation that our position should be that we're building on the success of CMG. That's the bureaucratic way you handle these situations, and that here's a whole new program that will have this. So, I mean, there are two things. One of them is we really, because we did this very successfully with EarthScope, is we worked with NSF to give them things that they could use to sell the program within NSF. I mean, then how we do this, there's a bunch of models. Dave Jackson could probably help us with, I mean, with Southern California Earthquake Center, again, that has a clear in-crowd and an out-crowd. Dave's in the in-crowd. We, of course, are in the out-crowd. But nonetheless, the in-crowd is broader than their original few institutions, although it's still, it's still sort of like getting into exclusive country club or something. But most of us are out. But at least they have a larger group that are in. Like Brown is in, Columbia is in. So in other words, it has been. Dave could probably brief you on the details, but it's, it is geographically somewhat distributed. Now, the more open it is, the stronger it is. One of the things that we did in UNAVCO was UNAVCO started off with a SCEC type model, and it was replaced with a model that anybody can join. And we, at both IRIS and UNAVCO, NSF will tell us that the most profound thing when we walk into NSF and want money is the map of the U.S. covered with dots. It says IRIS member institutions or UNAVCO member institutions. And so in a sense, what you do in a model like that is you go out and you start off totally inclusive, and you say anyone that wants to join, I'm on the board of UNAVCO, and every couple of meetings we rule on the admission of new members. So then we figure out a model in which in which we obviously don't, we obviously want a model in which funding and postdocs or so on will go other places, even if, for example, what NSF would probably want if you were running a postdoc program is they would probably want a prime contractor. But those postdocs would be tenable at any member institution, and you debate those. So, I mean, there'd be no reason. So the NSF likes to have a point of contact, but they are very comfortable with money going from there to other places.
Who do I call if I want to talk to Europe?
Yeah, that's what they want. I mean, when we started the Plate Boundary Observatory, it was $100 million, and NSF wanted someone that they could call and find out what was happening to their $100 million. But, for example, a fair chunk of that money, for example, actually goes to Scripps to operate a data center, and it goes to, obviously, the major facility of all their irises spread all over the place. So I think that the fact that you have a physical center somewhere doesn't mean that you're not supporting a lot of activities all over the place. It just means that you create and Dave can correct me on these things, but I suspect they must have had the same discussion with Sketch. They want a point of contact. And because, you're signing, by now NSF, for those of you who don't know, has become much, much more bureaucratic about these things. They view the contract they cut with an institute or with a provider, it's just like the contract to have the garbage collected in the NSF building. It's legally just a contract. But in an ideal world, for example, if we contracted, operate, if our contract, involved supporting postdocs, or it could be, and graduate fellowships I'd like to see also, and basically, and my thought in a lot of this would be that the sustainability thing is just starting. I don't think they really know what they want to do with that. If we walked in with a proposal, with a plan that would do a certain key component of that, the idea would be, suppose we're offering to say we'd like to train a new generation of graduate students with much better cross-disciplinary skills of the sort that are needed for serious sustainability studies. So I know we heard at least 3 talks today that more or less were hitting on that theme. But, I think there's a reasonable chance they might go for it. So I think we could concoct something they would like, and the idea would be we'd have to get. So, and the other nice thing, if we can get it under sustainability, is all the divisions are committed to it. The GEO will not at all object, I think, if some of the sustainability money, which they've blocked out, goes to something like this. I bet from their standpoint, it's entirely different from creating a new program. I'm not certain, but I have a strong suspicion if we went in there. And one thing that we had very nice chats at this other, this CMG meeting where they were told to their amazement that they weren't going to be continued. They all, I think, expected they would. One of the things that was made real clear was that they were open to a fair number of things if you could make a case to them. So I think there's a reasonably strong case made, and if you think about how much of sustainability amounts to making predictions about the future, and of which you know relatively little about how good those predictions are, either in the validation or the verification, you have very little idea what those uncertainties are. I think that's just some thoughts.
I'm perfectly comfortable with sustainability because I also work on economic modeling and so on, but it's sort of a slippery slope. It's a slippery slope because, then people in the social science say, it's going to be a very big tent.
Sure, but each division is putting money in it, so presumably they are going to each division will to some extent want to make sure that some of the money goes to their traditional constituents. I don't think it's like all the money would go into economics or sociology or something. If Geo or DMS or someone is putting money into that, I think they probably will be very happy to see some of their traditional constituency folded in under that.
Is there a danger in running something that crosses NSF divisions?
Sustainability is set up that way, plus, of course, CMG cross divisions. Right? I mean, that was its success, and that's what...
These studies are a pretty good model, Southern California Earthquake Center. It started out as a science and technology center, appealing to a particular NSF program, which was across specific disciplines at the time it started out. It started about 1990. And I think one reason that it was funded and that it field is, first of all, it had a focus. It said, here's what we're going to do. And that focus was to provide scientific basis for earthquake hazard estimation. And that was pretty broad. It included geology, seismology, strong ground motion, geodesy, a number of different areas. It was integrative in that it had a charismatic leader, Kay Hockey, who brought in other well-known experts. And that provided NSF with a kind of focus that it treasured, I think. It could say, we've got a class of problems that we'd like to support, and the Southern California Earthquake Center could say, we can do that. We can bring in the people, we can organize the projects. And one of the reasons it succeeded is that it had products that had a sequence of reports on earthquake probabilities and seismic hazards, and now it's got reports on seismic velocity models in 3D that can be used to trace through the lithosphere, model of faults with all the parameters that they want when they want to model those. And now there are about 8 or 10 models like that. And they're widely used, and they're clearly recognized as being a product of this interaction, something that individuals could aspire to do, but you need a team, you need a focus, you need some time to develop these things. So I think it worked very well because of those qualities. It started out, I think, rather slowly. It had some meetings in which everybody said, here's what I want to do, and it was all over the map. And it took about a year to get down to a focus that was pretty clear and that could form the basis of a proposal. And I would say that the first meeting that I went to was about as broad as this meeting in terms of the kind of foci that are represented as sort of candidates for what could be a gathering point. I don't really know the history of the organization as it stands and what kind of momentum it has. But one thing about SCEC is that once it got started and sort of satisfied these objectives, it couldn't be stopped. It's now in its 4th iteration, each one being about 5 years. The funding changed completely. It was a science and technology center. Now it's completely supported in the earth science part of NSF. And it gets some funds from the United States Geological Survey, the California Geological Survey, and other things. And each time it's to be renewed, people say, what can we do that's new? And it turns out that the new stuff is basically a little bit of frosting on the cake, doing more of the same, better, at higher technology, or following some of the ideas that had been listed in the first proposal. So if you read the first proposal, it's not that different from what's going on now, but the way it's done couldn't have been envisioned 20 years ago. So my feeling is if you get that momentum and you sort of pull in the air and the fire keeps burning, and it can be self-sustained in spite of changes in the way the organization is run. I don't see that focus yet. I think it could happen. I think there's sort of more distillation of ideas necessary to really get that momentum going.
Yeah. I'll make a comment. So I was looking at the talks, and for me it's kind of refreshing because I think the geophysics for a while. And so most of the talks were data analysis, model building, things of that sort. On the other hand, technically, I haven't seen much of sort of modern stuff that is being done, numerical analysis and light math. So one of the key things that will be offered is a mechanism for cooperation between geophysicists and mathematicians in form of common grants, which are the umbrella of some organization like an institute. So it can be Institute for Geophysical Data Analysis and Modeling, for example. And one of the things which I think is critical for himself is education. And so bringing in Math-Geophysics with good mathematical background is very important. So there can be some system of courses where basically people travel from one university to another. Now, the thing is that geographically it can be very distributed. These days, with Skype and everything else, it's so easy to communicate that I don't think it's an issue. So, this is kind of thing that, along those lines, which were suggestions already made. I think something like that. So basically, and the sub had this DMG grants, and it would be like engineering, but this organization between math and geophysics will be done outside of the centers. Self-organized structure in the institute or something. And along those lines, I think there's reasonable chance.
Well, one thing that apparently is true in the business community, we tend to always use these cheapy things like Skype. Apparently the business community, the multinationals have invested in serious high-level video conferencing. And apparently routinely, until you get used to it, at the end of the meeting, people reach out to shake hands with the other guy. They bump into the screen and say, oh yeah, right. But they said, really smart business types, when you start the meeting, you're aware that it's a screen. And the fidelity is so good that in a short time, people forget it. Yeah. No, I'm saying it's
I have a comment. It's this kind of institution. I'll give you an example. I'm an oceanographer. I work with NASA. I didn't get money from NASA, but I give you most of your best proposal. But oceanography, we have similar institution organized in Hawaii. Actually, it's NASA gave $1 million a year, and myself, NOAA gave about $1 million a year, and the Japanese government gave $3 million a year. So the home oceanography institution in Hawaii started climbing and oceanography. Then actually wonderful example. Of course, this grant is going to one institution, but the money actually distributed to a wide range of faculties because you can go there and visit. See, you have a lot of people who collaborate in the same institution. Say, for example, the Japanese faculty can go to that institution and that grant to work with American scientists. So the same thing I think is looking here. I think our proposal, many people get a guarantees in doing whatever you are doing in math. But this probably is a good idea if you have a clear mission you want to achieve. Here you have all the people who work together. The geophysicists or the mathematicians can be worked together, really physically work in this institution, whatever, in Chicago, whatever. They can have a chance to interact with each other. They probably can produce better results than separately or separate grant in each institution, because obviously this is a collaborative meeting research. For the good word of the the formula for collaborative actually is separate work. It's not a collaborative efficiently. Probably this step another way to do real collaboration. For example, there's many people who talk about this kind of hazard prediction, earthquake prediction, and hurricane prediction, and flood, and tsunami. But this thing is only geophysics cannot solve this problem, because they are doing observation, they can do prediction. A mathematician can do prediction, but they don't work with geophysics. Their model never been used in real time. So that's probably a chance to make a case, get the Congress or maybe the politician interested, this country that is interested, they have a case to present it. They say, well, we have something can be done better than the CMG formula. Cannot be done separately,
Maybe that's the only case where it's not cheap. Certainly the case that NSF seems to like novelty. The possibility of paying new money to Congress is always predicated on something new that often wasn't done under a previous program. I also remarked that the race models for postdocs, of course. Maybe what we would all like is simply more money from NSF to hire postdocs. And probably that's not forthcoming in that form. And MSRI, of course, is a postdoc program. You get a year at MSRI to start with their programs in a specific field. That's actually been very successful, but in a way, it never seems like a very satisfactory job. Somebody, when your position is difficult, especially with mathematics. Some kind of hybrid where you can have a year at an institute and then some time somewhere else with a postdoctoral mentor might really make sense because there's a possibility of having more honesty about postdocs, but facing this institute and occasion to get together and raise something in the field.
Well, if you use the argument that these people are being intrinsically trained in a multidisciplinary way, then your case for doing it longer. But similarly, I thought the idea with graduate fellowship is you say that in every department there's always pressure to put people to research work as soon as possible, and that actually comes at the expense of the broadening of their education. Whereas if you say, okay, we're going to actually provide the funding needed, then it's in a position to say to people, we'd like to have you, at least the bachelor's degree level in the other discipline. And if you put money in that, people are all quite bright and motivated, and there'd be people, no shortage of people interested in doing this if basically say, yeah, we understand that, you'll have 2 supervisors, and you'll have the funding. And I also was talking to Martin about this. I think, and if on the educational side, I think there's a very good chance that industry might be interested in putting money into something that would be training a sort of, basically a higher level of specialists that would just be better prepared than they can be now under the current funding system. Yeah.
I don't know how the other math sciences institutes are doing, but it seems to me SAMC struggles very much in getting senior people to make extended visits to the center. And so the leaders of the group tend to be from the research triangle area, and then it's a bunch of junior people. So maybe that's a bit of a problem with the other institutes as well, and that does
more and more an issue in MSRI.
Yeah, and that argues maybe for more of a more virtual institute where people don't have to go somewhere for 6 months to participate in a meaningful way.
Or when it's laid out in terms of shorter blocks of time, that one's mini courses.
Yeah, but you need the extended contact, I think, to really develop research programs. When you go to short things, you go to something like this, and you sit there and think, oh yeah, what that person does is interesting, and then you go home and forget about it. I mean, and I've been to lots of these things, and I know it's what happens. So you do need that extended contact if you really want to change people's research directions, and you need to think about ways of making that happen that doesn't force people to. I mean, it's very hard for people to take sabbaticals these days when everybody's part of 2 career families. It's a different world, and we need to think about how to encourage the interaction, but without so much traveling.
All right. I'd like to hear some of the same things from other people. I'm quite familiar with the institute that you're mentioning in Hawaii, but you're talking Spanish and Japanese people who really like to spend time in Hawaii. I'm not sure that the Japanese government is going to cough up $3 million for Chicago. But more seriously about this thing, again, indeed, let's just say that you want to interact with somebody else. That's a geoscientist, or if you talk sustainability, an economist wants to work with a mathematician someday. To time those visits to coincide with an institute is harder than to get, some sort of a supplement or sabbatical for somebody to just go and visit a colleague at some other institution. And again, I don't know how acceptable this would be to NSF to something. I think it would make a heck of a lot more sense to just send money for people to pay shorter visits to each other, and maybe having postdocs or graduate students visiting for longer. So it's still, Skype is a wonderful thing, and email and Dropboxes and everything, but there's still no real counterpart to being in front of a blackboard, 2 or 3 or 5 people and talking for 2 or 3 days about something. So I would like to see an effort to have more realistic versions of exchange programs between people that come they just come for semesters or whatever to one place. That should be part of it. There should be programs and there should be a feeling of having a home for this thing, and sure, why not Chicago? I don't guarantee that outcome here immediately after the surgery.
It works.
But
Well, what you described sounds exactly like the network program for mathematical research network program for mathematical sciences.
that's one component, not the entire thing.
Well, so that program has exchanges of people between different notes in the network. Students, you get the money to pay students to go to another node or postdocs. There's a fair bit of money for travel in it. It's a substantial amount of funding. It does not have research funding.
Yeah, but I think that we should keep that. We really should keep that, on a competitive basis, open, as open as possible. But I think that that's very important.
Yeah, if you look at the Southern California Institute, my understanding is that they have, the area to apply for money, apply for research funds.
Yes.
And both Michael and I have run programs on the APA where we had similar things. We had mini grants for people who participated in the program.
Yeah,
And that were very, very explicit that they do not want that in the context of the network grants.
Just point of information, the network grants do not support graduate students or postdocs for their salary tuition portion.
It supports them when they're not at their home institute.
Okay, but that's just travel expenses or...
Pay salary to go somewhere
tuition,
else.
everything, when they're not at their home institution.
So if you can get them to go somewhere else, you can pay their
So
salary.
that's a way to pay your students. It's the same way.
Yeah.
Okay. Good. I didn't know.
Yeah, well, we're trying to figure those things out.
Another comment, I almost every fall I teach a course on resolution and C. And at some point, on one of those School of Mines, I got told the students are doing very well this day. And these days we have a hybrid grant with optics people now, painting on our university, and so I got 4 people who do the optics. So I modified the course a little bit for them, but it's like 4 people. So 6 people, 8 people. So these days, but that was screening could become teachers' courses. Now, because it's Colorado system, they could create the Colorado School of Mines for this course. But the question is this: if you teach a course and there is this kind of institute, probably you can have students in different places. It doesn't have to be a gigantic class, but we talk about special topics. So if it grows to 15, 16 people, that's very efficient. Such system can be introduced because in any particular location at a particular time, you may not have enough people for special topics. So that's an educational component.
immersion. I agree strongly with that, I think. But it sort of is, I think, here, sort of suggestions to have some decentralized role, and which is different from the network, but it's sort of classical institute, right? I think it would be very good idea to get critical mass in those sort of multidisciplinary courses. Could administer very well.
So maybe a combination of the three. Essentially, centralized institute with semesters or whatever, that type of programs, some network, and some reals.
I also see another benefit. If you have this kind of centralized institution, it's better to partner with national lab. You can actually have resources to collaborate and collaborate to train students. You already get a student job there with an intern opportunity because you need to contact and need to interact with the scientists in the lab. So the students can be working directly with the national program. I think that's another benefit. Here you have centralized resource there.
So, I mean, I like this idea about having kind of virtual special topic classes that students from lots of universities can take at the same time. It seems to me in some ways probably more effective than these short courses where you bring people together for a week. I think you need that extended time for people to absorb something new. But then classes like that might be project-based, and at the end of the semester, you could bring all the students to one place, and they could present their projects and talk to each other. So you get a little bit of both aspects. But I do think having things, you need things to be for longer than a week if you really want it to have an influence on people. So I do like this model.
It's a waste of resources to have to teach 2 or 6 students. I mean, it doesn't have to be like others.
Right. No, I think it's a good idea. I like that.
What's the title of the course?
Extreme events of large deviations.
There's one example. Oh, make a few. Let me.
So I mean, just a few comments. There are so many good ideas out there, and I agree with all of them. Just point of information, talking about the existing math institutes. The standard now for the IMA is a 2-year postdoc, exactly this stuff we're talking about. The IMA started out as a 1-year postdoc, and it was sort of a disaster. And in fact, often some of the IMA postdocs were extended to 3 years. So I think that's a good thing to keep in mind. I mean, I think 3 is a good number. We talked about PhD students. I think that's something that would be novel here that none of the other institutes are able to do because the math institutes change focus every year, so they can't really train PhD students. One idea I can throw out there, one way in a sense you get forced in SF's hand is by getting outside funding, getting the commitment from outside funding sources. I don't know what that would be. Energy companies might have an interest. ExxonMobil is the largest market cap company in the world, I guess. So they're a potential source. And you're talking about matching funds. You'd say, give us, committing them to this money if the NSF gives the, whatever, $36 million a year. But there are also some rather novel sources. Insurance companies could be interested in extreme events. And even Lloyd's of London, which would be an interesting source. And that might be something that would really capture the global attention of the government with some novel private sources of funding. I walked with jumping out to the taxi, and the one thing he emphasized as he was getting in the taxi was you got to have community support for this. And I think this is what this is doing, is finding an idea that everybody could buy into. And I really think that's got to be done. It can't happen all here, but people need to go back and talk to other people. And you need to gel an idea that everybody can get behind. I just want to say one of the hard things to keep in mind. Everybody needs to understand what the benefit is on the other side of the fence. So mathematicians don't get a lot of brownie points just by seeing their math applied. Really what gets them brownie points is when they see a new problem and they develop new mathematics. And I really like this bartender analogy. I think this is a good thing to keep in mind. So you go into the bar, you have some problem, you talk to the bartender. You don't really expect the bartender to solve your problem, but you get some good feedback, And so then you go away and you realize that problem is a problem you want to work on, or you get some new insight or something, but you don't expect your bartender to really solve every problem you come in with. Now, why is the bartender there? What's in it for the bartender? Well, it turns out the bartender is doing a PhD in sociology and studying people with emotional problems that come to the bars. So I think that's a good way to think about why are the mathematicians interested in that? And it's helpful to keep that in mind, just so you've got a good balance. So those are the main points, but the final point to keep in mind is what young people said. You got to get the community support. It's got to be both math and geo. You need to have the geo people at NSF excited about it. You've got to have a concept that everybody can get behind, and nobody's sort of nibbling at the edges and saying, "Well, I want my own little piece here."
I guess we're storing enough now of the different ideas, and I think maybe if we're paying 30 minutes or so, we should start talking about the structuring this white paper.
Well, we still need to agree on the title. I mean, there are two things on the table now. There is math, geo, and there's sustainability. So, how you structure this is pretty obvious. It's sort of why, what, and who. It's a standard sort of thing, but we still need to decide whether, just how broad a tent we want to pitch.
Well, in this white paper, should we address what jumping wants?
Well, but said, has raised this thing, the possibility of making it even broader. So, we should really decide whether we stay with geomath or, I don't know where it's set.
He's out there on the phone.
Banging away. Yeah, I think if we spread ourselves too thin, it would not be the wise thing to do.
Okay, I'm happy either way. Need to decide first.
Let me just say a point about sustainability. It's going to sound like I'm making a pun here, but I'm not really. I think there is an issue with sustainability, and that is to make. One of the reasons you want to bring in math to underpin science is sustainability. Because if you look at science that's been around for 100 years, you realize it's got some sort of mathematical theory in it. If it doesn't, it's probably, just wandered off. People, it's very hard to convince the young generation if you don't have some equations and so forth to explain why you think something is true. So I think that's not a bad theme to bring up at this point, because there is a sustainability issue in the community, and I think, that's why the government fights the shutdown programs and say, okay, if we keep increasing funding of everything, of course, grows exponentially. We consume all our feed corn and we all die. So you have to cut things off and look for new things. Well, one way to say that you're keeping an area sustained is by building that in from the beginning, and that's sort of an internal test to see if you've got something that makes sense. So I don't think that's a bad thing to build in, and I think you could have the other kind of sustainability in as a major theme of the collaboration.
I mean, if you want to be practical, what we should be writing is some kind of outline and giving people assignments, giving people writing assignments. And if you want to get something done, you got to get people to agree to write something. So.
Yeah.
No. Whatever.
No, sorry, you were outside, so we just volunteered. Can't get a pick.
You can use this pen.
Yeah, I think if we have half an hour, we could write an outline out. It could even be written on that computer that's up there, you know.
What did I get volunteered for?
I was suggesting we try to actually write some kind of outline and assign people, give people writing this.
Agreed. I'm happy to be the person that gives the writing assignment.
No, but I was saying we could actually write an outline. If we've got half an hour, you can write an outline on a computer. You know,
Yeah.
everybody agree on it.
Oh, I would think so. Yeah. I was assuming we could make a start at this, and then tomorrow we could brainstorm
Yeah.
somewhat further and start fleshing things out. I think tomorrow will be a really good day. You know, we're going to have, as they say, we're literally going to end with a bang with Jay's talk, have planetary collisions, and then we're going to have I think a bunch of people have come up with some neat things to say based on our talk, and then I thought we'd go into that mode. So starting with an outline sounds really good. I think the thing would be to come up with a set of sort of initial kind of themes or some, you know, sort of people that were associated with some theme or some set of topics.
Well, let me suggest an even broader thing, that there's an operational side to this. So say, what would you do, and how will the money be spent? That we've been talking about that. What are the things you would do? And then there are the research themes would be another part of it. And then there's going to be outreach. And we talked about this, and I think outreach ought to be a separate discussion. It's very hard to do. It's very important today with NSF.
Yeah.
And that would just be something that would have to be addressed in the subsequent meeting where real experts on outreach.
I think first thing to say is that that actually concerns me the least. Having designed an exhibit, which some of you may have seen at the Field Museum, which has now been seen by 1 million people. But I think actually within this group we have those kinds of expertise. I think part of it is
That's fine.
So I wouldn't worry about that. I tend to regard that as something that's important that we can do, but we more or less know how to do. I would focus on. I thought your first 2 points.
Okay, fine. But I do think outreach ought to look like a top level.
Oh, it definitely should be.
Okay,
but in
fine.
some sense, once we have to decide what the product is before we figure out how to disseminate it.
I agree.
Yeah.
But okay. So operational, just say operational. That's, you know, what does it do?
Put outreach at the bottom. I think I would try I would say number 1 is scientific objectives.
Yeah, sure. That's fine.
I mean, I'm following Rich's point. I thought Rich was saying, and then operational. What are you trying to accomplish? How are you trying to accomplish it? How are you trying to disseminate it?
That's right.
Yeah.
That's right. Good.
Yeah.
I mean, the ideas have been really interesting here. Let me just, if we're on operations, PhD students is new. Distributed postdocs, is that a good way to call it? I mean, the idea of having people semi-distributed. So what I imagine that means is that there's base funding, and then somehow or other people apply to get a postdoc. And that has to be worked out in detail, but I think the competition for getting this additional money would be important.
Yeah, I think one way to do it, and I was hearing the same thing the other side, but you'd envision the postdocs as being members of an institute, and actually they come with a cohort. You know, they meet with the others, and these postdocs are tenable. And in fact, one thing I think that would be a very good move is that the postdocs are tenable in the sense that they're in this institute, and you know, so if they want to go to UCLA for a year and work there, and then they want to go to Woods Hole for a year, like 3 years something, they can work there. And the nice thing is, the money under this scenario, the postdoc is not being hired to work for someone. They will have an advisor, but they would have to have two advisor from each side, but they could go somewhere else, sort of as they felt directed their own research. I think the key thing would be that we would be trying to bring people to a fairly serious level of sophistication in one of the other disciplines.
And
That a PhD in one, but who were comfortable with, essentially we're at least the beginning graduate level, probably in the other, something like that.
So you're really going to say third-year graduate students for a year?
I think I would say you do this as a 4 or 5 year.
they would be,
Multi-year program.
Yeah, a multi-year, sort of like a Hertz Fellowship or an NSF Fellowship.
From local member institutions?
No, I think you'd apply. I think people would apply for it, and again, it would probably be tenable at any of the. It would be you could even have an arrangement where you apply to the program, and then it's tenable at any, like Hertz Fellowship. It's tenable at any of the member institutions. So and I think that has a lot of attraction. A, it would allow people to, if like they want to spend a year, they could go somewhere else. And it would be that if assuming NSF was going to let you do that, and then they would have a really nice attraction that it would be really competitive to very bright kids, because they say, look, come here, and then then basically then there's a bunch of advisors who at different schools who are offering different programs. See what interests you.
Just a logistical thing that might be a difference in cultures between the math sciences and the geological sciences. And math sciences students are often expected and needed to teach some of the time.
No, SR hours.
But even as advanced students, so the notion of students in the math or statistics departments being on grant money the whole year, it happens, but it's not the norm. So you might be able to actually make your money go farther and more effective by instead of throwing a lot of money at a small number of students, spreading it out a little more.
Well, one option is you give 9-month fellowships, and then the students can then the school can either say, okay, you're a TA for a quarter, and we fund you over the summer, or
yeah. So that's right.
Yeah. I mean, no. I think you'd very much want to provide in this that as part that you would definitely want people to be TAs, and you would want people to have that teaching experience.
In our department of UCLA, also some fraction of time TAing is compulsory for educational reasons.
Mm-hmm.
Yeah, I think that. So I think that's right. I don't think there's actually a difference in the cultures here in this regard.
Math students teach geophysics.
I still don't understand where a student can take first-year graduate.
Well, what I would say is let's imagine you apply to this. Let's assume NSF was, but let's presume you apply you get one of these Math-Geo fellowships ideally, and then there's there's a dozen or some number of schools at which you can do it, and then I would say they would have the option of you could take your fellowship, you check the box, we've been working with the fellowships. Where do you want to go? I want to go to UCLA. Okay.
So did any of it involve being in there has to be a common.
I think one would but I'm saying, that's what I'm saying. But they could choose to use that fellowship at UCLA, and I think we'd probably have a summer program again or something to create a cohort of this group. That they would spend a month together every summer.
No, that's a very good idea.
Yeah.
So, but that requires, that will require a lot of negotiation with NSF. I don't think they have any program right now where you get, the money goes to the student and then you can use it, but only at a limited set of institutions.
NSF postdoctoral fellowship.
No, but there you say where you're going to go, and then the NSF doctoral fellowships, you don't have to say at all. You can take that anywhere.
Right.
So being able to take it to a limited set of institutions would be something new for them. I'm not saying it's a bad idea.
But it would be an interesting experiment. I mean, this idea of really creating a cohort that's
You can only use it at certain schools.
Is part of.
Yeah, I think it would be open to anyone. It's just that there would be a set of criteria to get one of these Math-Geo fellowships. The agreement would be that the program would have to meet some criteria that we could define about. You need to be at a certain level in the other, whichever you consider to be a primary discipline. You need to be at a reasonably high level at the other one, and that this would be an open thing. I mean, there always other place to offer it, but this used to be agreeing that this is what you do in exchange for.
joint mentorship takes care of this to a larger part. If you require these students to be jointly mentored by people from either side, that works. And I've been involved with programs in Chicago, in the bio area, Chicago and in Houston. And it works extremely well. The students love it.
Sure, and this way, basically, by providing the funding for them, they're not under the pressure to go on a research grant as soon as possible.
That's right.
So, if someone, if they say, we'd like you to take another 200-300 level, statistics courses or something, the people you recruit into a fellowship like this will say that sounds great. And the nice thing is that, but the funding is there for them to do it.
So the other concern I would have is the big commitment for a student who's just still a senior in college to say they want to commit to this kind of joint program. And so the other model is to offer it to students who already maybe done a year or two of graduate training in one discipline.
Think how many of these kids now, compared to when we were in school, are getting multiple degrees.
Yeah.
So I see this. I think it's the opposite. When I was in school, okay, I could have taken another math class and gotten a math degree. Okay, but I knew I wanted to go into psychology. When I was in school, you didn't get 2 degrees; you got a degree in something. Now all these kids are, and math and something is actually a fairly common combination. Math and something.
But it's different to commit that you will.
Math and geo is common in some places. Brown is relatively common. Math and physics, of course, is common in most places. So chemistry, biology are common. So I think actually the kids are increasingly comfortable with that kind of stuff.
Statistics, students come into the programs often not having a clue what they want to do, or if they do have a clue, they end up changing their minds later.
Yeah.
And so for them to say, I'm going to take this fellowship, but it's going to commit me to working on something that involves geo in an important way, that's a pretty big constraint to be putting on them before they really may know what they're interested in. So I guess I would push for also having a way for students who only been in the program for a year or two to also get involved.
Well, I think you could have a panel that people could enter it either
right.
as a
so I just would
3-year fellowship or a 4-year fellowship.
I just want to keep some flexibility.
Well, my colleagues at UCLA in the statistics department do work in earthquakes. They recruit students, and they encourage their students to work on earthquakes. And it seems a very natural thing.
But those students don't often show up the day they're there saying, I want to work on statistics of earthquakes. They get drawn into it after they're there, I think.
Well, something like this would have been attractive to me. I applied to great places, Quran, Berkeley, and essentially Minnesota, because it had those people in the aeronautics, the aerospace department, Dan Joseph and so on, and people like George selling that. And maybe I was more mature than the typical American student because I was after military work.
I think a lot of people in this room might very well have done that if the opportunity existed.
Attractive to me, I won't tell you how many years ago.
Is there anybody else who's concerned that we're talking about how to do it rather than what to do?
I hate to say it, I think we got, or I should say you, because I don't really work in this field. I think you've got great ideas, and I think that they can be put in a nice package. I mean, you are literally saving the world. So, from earthquakes and meteorites and whatever, I'm not so concerned about the science being sold. I think it's more the mechanics of it that is, there's some really great ideas here, and I think they're necessary in this climate, to sell to...
But you raise this point of selling it to colleagues who are not going to necessarily get money from the program. I think that's really an essential ingredient to get some support. And I think we have to ask ourselves, if some other group were making a proposal like this, would we support it? What would we feel that either ourselves or that the community is going to get out of it, rather than just having NSF do more individual grants?
Well, we in our department are supportive of this new graduate program in applied physics, and we don't have any fundamental role in it. It seemed like, it seemed like a good idea. We were willing to make a modest effort to help them out. It's not our primary stock in trade, but it seemed like a good thing. And, we all said, gee.
I'm not saying people won't support it. I'm just saying we need to offer them a reason to support it.
Dave, SCEC did get favorably reviewed 3 or 4 times. In spite of the fact that, there aren't just content people about it. And, I remember once being asked to review the proposal for renewing the support of this Woods Hole summer school, writing that, oh yes, this school has been very, very productive. As a matter of fact, anybody who's anybody has been to that school. So actually, I'm surprised that you would send it to somebody like me who never was.
Well, one reason
Didn't
that-
review me favorably.
One reason that
Come on,
SCEC was
it's a good
supported,
idea.
one reason that SCEC was supported by outsiders was that there was the promise that the U.S. Geological Survey and the academic community were going to work together. And the U.S. Geological Survey had had a focus for Central California and done most of their work there. And the Southern California Earthquake Center is going to focus on Southern California. And the survey said, we think that's a good idea, we'll put some money into it. And people who didn't necessarily expect to get any of that money said, you know, this has been a problem for a long time, and this is a solution to it, and it would have worked.
I mean, I reviewed those over time. You know, and again, my sense is, you know, on the whole, I thought it was a good thing. When you distilled the hype out of it, I still thought it was a pretty good thing, and you know, I was giving it favorable reviews. And obviously, there must be enough people like me because all the reviewers are not. They have tried to maintain some level of arm's length in the reviewing.
Right.
And I mean, I know that's hard. I mean, Jim Wickham has said to me, I don't respond to the originally request to review it because I don't think it's a telephone book sized thing. And then they call you up and literally twist your arm to review it. And they say, all right. But, you know, obviously people are giving it good reviews.
But my sense is because it had a scientific problem or set of scientific problems,
Yeah, no, that
Well, but there was a list up there before,
We have
right?
the
So
other
I
few
guess
lists, and
maybe
we can try to draw what we think are the best of those.
I think the point is what Dave is saying and what Rich was saying is more or less the same, that, you know, we're going to want to have some relatively clear foci, and especially if we're trying to sell this internally as some way to build on CMG. So it's not like, I mean, obviously if this appears to come out of a general grants program, then the answer is, of course, it will get very negative reviews. If it appears to be a way of, you know, we say, you know, CMG, and then I think trying to build some connect that this is somehow fits into the spirit of this sustainability program, because we're writing a white paper now. We're not writing a proposal. So we're basically saying, you know, that we think that this could very much be part of a couple of key things that NSF is doing. And we're inviting them to figure out bureaucratically how to do it. I mean, this is what we did with EarthScope. For those of you who don't know, EarthScope is about $200 million. And basically we said, these are things that are really important to do, and NSF should do them, okay? And, you know, we didn't actually specifically, obviously we didn't know how exactly NSF should go about doing this. And interesting enough, that's what they wanted. They basically said, tell us why this is a good thing to do. And once they decided that they were interested in doing it, then they thought about how bureaucratically they should accomplish it. I mean, we can't create it. If we come out of nowhere, then they say, well, gee, we don't have money. If we say, here, this is relevant to some things. So I think we can define a couple of, I mean, basically, in a sense, the way I always told people when we wrote the white papers for EarthScope and Pipe Boundary Observatory was, you know, give them something that they can sell higher up in NSF. That's what they want, a set of bullets, like really clear, very clean, that they can sell at his associate director level.
I would still say to scope it, you know, it's fairly easy to find out exactly how much money there is in the CMG program, because all you have to do is to go on the NSF side.
Sure.
It's an idea.
The principle
I'm
that
still trying to scope it to about that level.
I think that's a very good idea.
You know.
Yeah.
Scientifically, this is sufficiently coherent.
Well, we should edit it down a little
You
bit.
have to structure it a little bit more.
I mean, the question is, if you're comfortable with the top four, the other things, we need like no more than 3 to 5 major themes. You know, I hate this grand challenges word, but that seems to be the new bad one. But, and then other things can all have to fit under a set of basic themes, but they need a fairly easy and clear set of basic themes that they can articulate, and that can't be too methodological. For example, like, let's pick an obvious one, mathematics and imaging goes under understanding Earth systems, okay? The goal of imaging is to understand Earth systems in this formulation, okay? Other things like discretization versus continuum errors goes under that second category of computation in the digital laboratory.
I would say that given the content and the number of the talks that we've seen, perhaps rare event deserves a promotion.
Yeah, I was viewing that as under predicting Earth system evolution.
So remember, the bartender has his or her own point of view. of this, right? Yeah. And maybe that wouldn't be crazy to show that off sort of first class and say, look, if you're coming from the geophysics side, this is the way you see it. But if you're from the math side, you wouldn't have to elaborate. You'd just say, you would invert the topics.
That's not a bad way to do it. Let's see if we could come up with a formulation. I mean, so a good way to put it is a formulation that an earth scientist looking at it would say, yes, that's a very sensible way to think about it. And a mathematician or a statistician looking at it would say, yeah, those are really interesting problems that would be worth our putting serious effort into. And to figure out how to do that.
I would group model robustness with uncertainty quantification. I mean, I don't know what modality fusion is. I think that something like, model, I mean, this thing about the fact that these models are really just getting too big and we need to be able to say something about
Jared, would you like to actually try doing that on the screen, is seeing if we can agree under a couple of those major themes, and then now again, that theme was, and then we'd figure out, and then we'd try to figure out Ridge's point as to try to whether under each of those categories we could come up with a formulation that explained why this is mathematically desirable, or whether we should simply have a parallel, or whether just a parallel for a set of themes.
This is getting close to wordsmithing, but if you accept the concept, I think this could be worked out. Because remember, you've got sort of complementary.
You have a matrix. You have
a matrix.
The 4 geo topics, the 4 math topics, and you show how they each show up in almost every.
And the criteria would be
almost a dense matrix.
But you have to, for example, rare events. You could sell to the mathematical audience because there are theorems there. As we heard today from George, most applied mathematicians don't know these things. And it's going to be an area that will explode, I think.
I think that was I thought George's talk was a fantastic example of just how we, of how to develop these kinds of ideas. So let's try to do that. And I think this, there are other cases I'm trying to remember, but like when RAND was set up, I think RAND was supposed to basically work on problems that had fundamental, deep theoretical challenges involved with them that were relevant for national security. There was a matrix there, and obviously they had to be, in theory, they had to be both to meet their goals. And we could, basically what we're saying is we're trying to articulate projects that meet that criteria. They are important. They are important in terms of understanding the Earth, and they are important mathematically, and statistically.
Maybe as a very good look to the mentorship. We have experience with it because that's the department has set up and has an additional program. There is a distinction between graduate students in sciences and in math. So in science, they start research the first year. In math, we cannot send them out before they at least take 1 or even 2 years. Because they need to get prepared. And except in this IGEP grants doesn't allow us in that program from the beginning. But we kind of do it in a special way so that math students and applied math students start a little later. Because they have to first learn and then decide what they want to do. And that is a nuance that has to be sort of built in. Otherwise it will be difficult technically to do. So that delaying the start of math students for 1 or 2 years before they get enough math. Whereas science students who intend to just learn enough math and do it a bit later. So they learn the subject first, and then they grow up whatever they can in math.
I totally agree with your statement, but here's the thing. If we're trying to configure a fellowship program, then we are really looking for either math students who would like to learn a fair bit of science, or science students who would like to know more than the bare minimum of math and would like a program where basically these people like math. They see themselves as, biologists or seismologists or whatnot. They like math. They would frankly they will happily go further in it with a structure that allows them to do it and encourages them to do it.
There are also great math students
the same.
who want to go into sciences as well.
Yeah.
So What I'm saying is this is not reversal. I mean, they're not equivalent.
Well, it's not, let me just say, because I sit in a math department, but I also sit in a computer science department. And the computer science students are run like you're saying the science students. They start research, day one. In addition to taking a bunch of courses, and I think you could do that in pure math. Sure, they've got to know measure theory and they've got to know the basics, but they could also have a reading course where and be involved in a research group where they're doing, let's say, mundane things. I mean, let's face it, applied areas have some mundane things that have to be done.
But this is not the problem. The problem is that when you get, say, 20 new students, you don't know which one of them are capable of doing two things at once.
Well, I think this program is going to attract some pretty impressive people, and those people likely will be able to do that. I don't think this is going to be the sort of support that you give out, and then you kind of see who arrives and who looks okay, and then you say, well, how can we split up the funding among these two people? I think this is going to be a real program.
In our experience, it works better if you reverse watch them for a year, at least.
I think
And
there's a
they
detail.
take both ways. Sometimes you get very good students who underestimate themselves.
I think this detail, how you educate, how you train the students. I think the university trying to train more students, but I think it's I'm from outside. I want to see how you figure out that they find a job. I think that's a perfect example. This kind of job institute have both math and geophysics. Doesn't matter how you educate them. It's useful for them to find a job. Yes, I'm looking for some people for post or something. I often find people either from math apply to me or from oceanography or geophysics. Because I need some people who know who have strong mathematical background and also know geophysics. So I cannot find good candidates from either both this department because I cannot train math students. For 2 years, my grant only 3 years. They finish, they cannot do my work. I cannot get a oceanographer for a student to do my work because they don't know too much of math and computational skill. So that's the trouble for me. I think that's many of the national labs.
Right.
They try to hire this kind of students. The university don't produce those kind of students.
Well, yeah, I think the point is with a program like this, we're saying we'd like to try to produce a different class of people that, so obviously you have to start with people whose inclinations run this way, but I don't think there's that much of a shortage of smart people who would like to do this. I think if the funding were there, I don't think we'd have very little doubt.
Finding people.
Yeah, I think Jared and I serve on the committee here that sort of preps students for their Hertz Fellowships interviews. And, frankly, we get 5 or 6 a year. Again, that's across all science. But, there's a lot of smart kids out there that really would like the opportunity. So I don't think we should be worried. I'm not saying in a sense, let us do it. But I think if we raised, if we provided the opportunity, I don't think finding applicants interested would be a problem. We find a fair number of kids that are vacillating about, geology versus math versus physics, and there's a fair number of such kids who would really have an opportunity to continue.
We're talking about a final paper here. So what's really matters here is fresh, new ideas.
Yeah.
Let's not worry too much about details.
Right. Yeah. Agreed. Yes.
No, I really like the virtual classes. If we can get that on the other one. I don't want us to forget that.
Well, I thought I heard kind of a theme in many of the presentations over the 2 days, 3 days really, which was somehow bridging a gap between deterministic models and stochastic models. That there are a lot of models that are phrased deterministically. We know there are a lot of things in the inputs to the models that have been simplified a lot. And we know in many cases that the output of it is going to look stochastic when it comes out. So I think developing a good mathematical framework for bridging that kind of gap might be a cross-cut.
Well, that could easily be one of, Rich's, what Rich's matrix, in fact, I think that'd be a great thing would be to go back and work on that first one to try to take all the topics on the bottom and put them into one of those 4 geo boxes, and then I would suggest we try to create the analogous math box.
But I like that category because, like I argued before, in some ways the biggest gap in this room is not between the math scientists and the geoscientists, but the PDE people and the statistics people, and we need to bridge that gap at least as much as the other gap.
Well, I think that's an excellent point. I mean, to tell to the math community that this is a place where those things have to meet.
Yeah, that's right.
And so I would think that should be, if Rich were comfortable, that should be one of like the 4 math themes.
Yeah.
The four. So I would start with a set of bold bullets, basically the math themes, and one of them could be, we can phrase this in any one of several ways, but bridging the gap between stochastic and deterministic, or however you want to do it. That
we're eventually going to have to ask people to contribute things. It's obvious that George can write that. He does that.
Right.
And I think in a way, that's what you want to do is identify the right people and get them to contribute.
George told me he'll do it.
Yeah. I think he seemed very positive about it. And
he told me personally that he'll contribute to the...
So what I'd suggest, Jared, is my suggestion is how to do this is take the not bold things, starting with model robustness, and let's try to move each of those under the 4 grand earth science themes. Okay? Then similarly, I think we should let Rich and Mike and everyone else involved try to define 4 themes that they think would make sense to mathematicians reviewing or thinking about the project, and that's things that would be interesting that enough that
that's right.
Smart kids that view themselves as primarily mathematicians, but would like to be involved in something practical.
Yeah, and maybe the thing to do right now is to duplicate them. So, for example, rare events, mathematics of imaging are going to survive in this math.
That's a good idea. Duplicate all of them. Yeah, right. And then we try to.
So I think numerical methods is something that will also appeal to both the statisticians and mathematicians. Statisticians are finally coming to recognize that we need to think hard about our algorithms and how we compute things, and then allows us to bring in the machine learning people who think much harder about algorithms than traditional statisticians.
One thing we might even with this is that we had computation of processes in the Earth System Digital Laboratory because we were trying to put that category of things out there that could be conceivably moved down and made one of the math themes. In other words, if it's a computation theme, it could be one of the math themes rather than the geo ones. So the geo ones would be about problems,
right?
And the others would be about
techniques,
techniques,
solutions.
So so that does that make sense?
Let me suggest modification of one of the lines there. It shouldn't be numerical in algebra. It should be numerical tensor algebra, and it shouldn't be massively parallel computations. It should be fast computations on parallel computers.
Can I suggest at first let's try to get the big themes and then let's change it to that?
It should be high productivity computing. HPC means high productivity.
Yeah.
Also, there should be joint libraries.
But I think that we want to sort of, but so Jared, are you comfortable with that, taking this computational thing and moving that down as sort of a math theme? So I would say, yeah, what I would do is start another category that says math and statistics, and put that under there. And then so this would again would be the matrix of.
No, wait, don't lose it.
No.
He just
I don't know how many buffers you've got here.
Yeah, math and statistics or something.
There you go.
Yeah, very good. And then then I think Rich's idea was very good. Let's duplicate these more specific things. Let's try to assign them to the various.
So are we short of
Well, I think a matrix
No, I
in the
think
end
that's
is...
fine. I think that's fine because we moved this. I think I think there's stochastic and deterministic thing we want under as a major thing under math.
Exactly. And I think ultimately there'll be a matrix.
Yeah.
Which will, connect these things.
Exactly.
I kind of like the 4x4 matrix. 3x3 feels a little small to me.
Yeah, 3x4 matrix.
You'd still use Kramer's rule for doing 3 by 3. 4 by 4, you wouldn't have to do that.
There's no physical analogy.
Okay. So could we try to articulate this, maybe someone articulate this deterministic, Dave or Rich, someone, this deterministic versus stochastic theme?
I just want George to write it. I mean,
Well, no, but we need to articulate it for our own thing.
Well, to me, the interesting is to trying to combine them, to bring them together. Is what's often done is this kind of, you have your mechanistic model, and then you assume it's plus additive noise. And that, to me, isn't quite it, right? To me, the interesting talks and the interesting things are to integrate the stochastic element into the model, into the dynamics of the model.
Maybe that should be the subhead, integration of stochastic and dynamic modeling?
Yeah, I think that would be a good way to say it. That's under math.
Under math.
Yeah, integration of deterministic and stochastic.
But it's certainly applied to both the predicting evolution and understanding persistence.
Yeah, no, I think
so it'll
all
cut
those things
across
would fit
all
under
of
there, but the idea would be that the earth science themes would be about things viewed from the world as a geoscientist. The other dimension of the matrix would be viewed as a mathematician. And almost all these topics will appear, obviously, each element will be in both a row and a column.
Right.
Okay?
You wouldn't have just that math. Can you hang every other math thing you want to do underneath integration of stochastic and
No, I don't think it covers everything.
No,
I mean, it's really different to talk about accuracy, stability, da-da-da. I mean, these
I
are...
can talk about all those in the context of that. And if it's, if you're just going to list all the math things you do, I would rather, say something different that no one else is doing. I can already put everything I want to do under that anyway and justify it. But if it's one simple thing that you can tell me that you do that no one else does, I think that's better.
Well, but it depends what we think we're doing here. I would like to see us kind of, at least in part, giving a vision from the field and not just a pre-proposal.
Yeah, I think part of this, we want to recognize that there are a lot of things which, a clever, the optimal thing, the bartender can deliver to you is an analytic solution to some problem that you haven't figured out how to solve. Obviously, that would be your dream. All the things that we're mucking around with numerically with both don't work very well, and someone says, hey, what you really need is the following transformation. So that's why I wouldn't try to put everything in the numerical box.
I guess if I'm reading it, I'm just thinking what I'm going to think if I read this. So if I'm a reviewer, I've seen a bunch of stuff that everyone does, right? Why would it be special here?
So you'd want to put that under integration of stochastic, everything under integration of stochastic and deterministic.
I want to be convinced, like if I'm writing down, computation and accuracy and stability, of course, everyone cares about that. So why would I care about stability here and what would I be doing here?
You're saying
I guess the rare events thing could go under that. I mean, if from the math and stat side people are comfortable with rare events, I'd really like to see that there. Because boy, that is a help. That is a help if I have to sell this under a sustainability framework.
Yeah.
Already in Racing talked about modeling round-off error and the stochastic process when we might implement it. Okay?
That just didn't work very well. No, it didn't work very well.
Bad noise.
Well, Matt, I'm missing your point. You're saying accuracy, stability, that's all mom and apple pie, that shouldn't be here?
I'm saying that you have to mention all of those things no matter what you talk about. I could be writing a proposal for anything you care about, and it wouldn't have to do with accuracy and stability, and that's that. So I don't need to put that separate. I can just say, talk about a thing that we're focused on, that everyone agrees that we come together, we do it better than anyone else.
Right, and that's integration of stochastic determinism.
That's right.
Yeah, I think that's a top-level bullet. I mean, that's really the new...
No, that's correct.
Oh, yeah, I mean, that's meant to be of the same stature as that.
Yes,
It's just
right.
that we
We definitely want
haven't
that.
gotten the fonts right yet.
Definitely, we're all agreed that it's one of the three. The question is the only
that should
one.
be both.
Is it should be,
That's
could it be
both.
one of one or one of three?
That'll
That's something
maybe
we're talking
clear
about. We're agreed that it should be one.
It's just the wrong font.
So definitely we want that bolded.
There we go.
Yeah. Okay.
And
And
whether
rare
you want-
events are under there. Now, inverse problems and mathematics of imaging, I think, I agree with George. George has sort of spearheaded this whole area of mathematics of imaging, or imaging science, as he calls it, and I think it belongs as a separate, bullet. It is.
Yeah, I was viewing that similarly. I was viewing that, and it would match up to the understanding Earth systems thing. And again, it has this strong tie with energy and sustainability, which I think is a big seller.
Now, the thing you just cut, the rare events, goes under the integration of stochastic and deterministic models.
Well,
Yeah.
I'm not sure about that. I'm not sure. It could, but it could be big enough to deserve its own.
Right. The thing is, I think intellectually it could go under integration, stochastic, and deterministic models. If I were having to sell it to an associate director, I would like to have that. Yeah.
Okay.
That's why
But it only makes sense as a stochastic model, right? Rare.
Yeah,
is a
but
stochastic
we're allowed
model.
to have stochastic in more than one category.
Fine. Okay, that's fine. I just want to make sure.
I mean, this is why
That's fine.
on our meeting abstract thing, I put the Tohoku tsunami going over the seawall as sort of a kind of an spectacular illustration of this example of how do you think about rare events.
Now, there's another thing that belongs as a bold math thing. What do course models get right, and why? Can we prove, can we prove anything about the relationship between two models? This is a really interesting applied math
I agree
topic.
with what I said in my keynote talk at the CMG meeting, that, having, proving robustness across a hierarchy of models, in the spirit in which literature time will prove that you get actually shallow water solutions that's a living, that is,
That's it. Yeah, that's it.
COARSC.
Yeah, we want a different course.
Progressive refinement that doesn't screw up.
Yeah, I would even argue that anybody can write down, let's say it's fluids, Navier-Stokes equations. Well, okay, great, that's, or quantum mechanics, Schrodinger's equation. If you can't solve it, you need a toy model that captures the physics, and then that should match up in some way with your detailed model. If you don't really have that, you don't really understand the mechanism of a physical phenomena. So I mean, it's a message for.
So it's not a bold topic,
mathematicians.
but I think a couple of the speakers talked about the need to not give up on toy models. That they really could. It's one of our best way to learn things.
Yep.
Well, that's that
So
line about you have exact models, you can solve approximately or approximate models, you can solve exactly. A lot of times you get more out of the approximate models that you can solve exactly. You can explore the parameter space in a
You have to
in an
phrase that
intelligent
very
way.
carefully. I wouldn't use the word toy models.
Right.
Well,
No, no,
it's
no.
a good
And I
point.
think what Bruce talked about was a model in which you're a long way away from reality. It's a problem motivated by a real geophysical problem. And you're doing a real mathematical problem to edge towards it.
You want it to capture some essential feature of the real
I
system.
wouldn't
Yeah.
call that a toy model.
No, I would talk about, at least in the tectonic side of geology, the gods of the business, the Dan McKenzie's and the Norm Sleeps and so on are the people who have this uncanny ability to extract a very, very simple piece of behavior and announce that that's the important thing to think about. And 50 years after they pose this thing, when you want to think about that problem to first order, you always say, oh, I don't know, let's try that, It's got 4 parameters in it or something. It always seems to get the basic behavior right. And that's what, so when I heard Carrie Emanuel's talk, I had a sense I was hearing the same sort of thing in the atmospheric side. Yeah. So yeah, well, I think that we'll try to articulate that carefully. And what's nice about that is it's defining as a theme something that we all know at a gut level is really important. But I don't know how much anyone's actually tried to explicitly confront this issue. At the math level, is how do they do this? I mean, right now it's all done in a very seat of the pants way by very smart. Well, the successful ones are done in a very seat of the pants way by very, very smart people. And they seem to get it right.
So can I just recall Greg's suggestion, instead of numerical linear algebra, you want numerical multilinear algebra? It's a new rage. Tensor algebra, should it be tensor or multilinear algebra? Which is?
Can be both.
Okay. We could argue offline about what we should change.
Yeah, why don't you see how many of
parallel.
those things can be moved, can be grouped under, one or the other of the grand themes. Like right now we have a non-square matrix, but maybe we can say about that.
Are there any of the mathematical techniques that can't apply to all of those?
No, but some will more naturally fit in some of the others.
Yeah, but what he's saying is the things down there, when we move them up to get them. So the model robustness goes under something, under integration of stochastic and deterministic models, something like that. You can put it somewhere like that.
I would say put it underneath and not bold.
Yeah, exactly.
But then it also at least as much goes up into the characterization, uncertainty, quantification.
Right, and in some way that was my idea, was that in a lot of these we would also try to find if they had a natural home in the other categories. So I would, model robustness, I would probably put under understanding Earth systems. Obviously the first and the third would work, but put it somewhere. Rare events I would put under predicting Earth system evolution, and it's in a separate category at the bottom, too. Yeah. And then, mechanics of imaging would go under understanding Earth systems, and on the Earth science one it would go under probably computational processes in the math one. Yeah.
Yeah.
Mathematics of imaging. Put it under understanding Earth systems.
Mathematics of imaging is its own freestanding.
Right. Under math, it's a freestanding. Under math, it would be a freestanding entity. Under geoscience, it's a tool of importance toward understanding Earth systems.
Does maybe something about emerging models and models across media, could that be a main goal in the Earth, in the geology side?
Yeah, if we could articulate that well. I mean, because we're trying to make.
It seemed to me there was these interesting issues of the timescales for oceans are so different, for atmospheres and ice sheets. Are different.
Okay,
so,
yeah.
And that's part of what.
Right. I would sort of put that under. I would
have
put that under the understanding Earth systems thing. Okay.
I'm just trying to look for a fourth Earth
A
science.
fourth. No, I agree.
When that makes it to that level. We can't have one bigger than the other.
That'll cause problems. Have a room full of math people who are desperately trying to produce a square matrix rather than accepting that we can work with matrices that aren't square. But
well, it would show
it's got to be an
originality, brilliantly if we have a rectangular matrix.
It is true. And you can do it because the paper is not square.
Yeah, that's right.
The paper is rectangular, and so it's easier to get more lines.
It would also show a sense of
you had all this time discussing the Wonder-Rockies contribution to be able to should put a matrix that is square.
Now that would be very sophisticated.
Yeah.
I don't know if you want to go into this, but the software that you use. I mean, usually each researcher has its own software, and there are very few interchangeable ones. So if one can create sort of reproducible software or software libraries and make it part of it. I mean, there are tons of Poisson solvers. There are no techniques actually to do it so that it's general.
That's a tricky one because on the one hand, it opens up whole lines of funding that one does not have access to this. On the other hand, the question is, does it make it sound too much like other programs that people are doing? I don't know.
No. In fact, this is one thing that is quite rare. So there's lots of computational programs that don't take software seriously. And what I preach is that scientific computing is a three-legged stool, and it's math modeling, I call it, for the the physics side of it, and computer science for the software side of it. And it's a separate discipline, And I'll now turn the floor over to Matt if he's still with us, if you want to comment on it. But I mean, it's a huge area, and it isn't represented here. And to be honest, if you're talking about, you know, big, what's ultimately going to be big codes, well, you don't write those in MATLAB. I mean, maybe you sketch something out in MATLAB. That's where your toy models are played out. But for real codes, it's a different business. We've got a program in Chicago, and we have students that have been graduating the last few years, and they're very successful, and they know modeling, they know a little bit of the math, and a lot of the software.
Where relative to our matrix would you put that? I think let's get.
Well, then it really does become a tensor at that point.
Yeah, but so if we could drag into the division of computer science, then we can need our three-way array. But,
yeah, we don't necessarily need tensor, but we do need a three. We do need a something rectangular.
Math tap to OCI.
There is a geophysical purpose for it. That is, somebody should be able to take your data, take the software, reprocess it, and see whether he will agree with the results.
Yeah. Well, one of the ways to put it relative to this program would be that an enormous amount of earth science software, you know, at the 70 or 80% level, what's underneath it is basically mathematical software. In most cases, which is we've all just sort of pulled off the shelf somewhere. Probably it's like 40 years old, and God only knows if it works and under what conditions it fails. And I mean, probably everybody in this room has had horror stories with stuff they've always used. Now, so I mean, I think you could the trick is, how do we fit that into our framework here? I think it's a really good idea.
Well, I mean, there are other aspects of CS that have been mentioned, and that is big data problems. So that is generally viewed as
one way to do it is to make that a fourth earth science bullet, and to put a couple of these things under it.
Now, you could simply have a third category, and there are few of us in the room who can represent that and could draw more people in, and that would make it very compelling. I mean, it does, sure, it changes the scope, it makes, in a sense, harder for the students. I don't know how you deal with that. I think having 3 mentors is a bit much, but you know, you could have 2.
You just have a boot camp in all the problems.
No. It's not so simple. It's like saying, oh, math. Well, we'll just go to the library. All the math we ever need is in the library. It's no. Boot camp is not. People get PhDs in computer science, and they go out and make a whole lot more money than people in this room. There is a huge amount of substance there. You don't just get it in the boot camp. You get it by studying the subject and learning how people in computer science approach software.
Well, that's algorithm, but
it's software.
We can talk about the applying. There is another part to this. You see, in the topics that we saw presented, well, some of them are rather controversial, like sea level change, all those things, and it needs to be opened up in some sense. That is, people should be able to take data, apply their sort of own ideas to it. So there should be data banks, and there should be software.
And software banks. A lot of a lot of the scraps that we've been engaged in about earthquake hazards have been because the software is proprietary. We've had to reverse engineer it to try to understand what these people are actually claiming and how they got it.
Right.
And so I don't think it would be hard if we wanted a fourth earth science theme to put this under as that theme. Obviously, the same material will go in various places, but it could be put. I think it wouldn't be hard to make it. I mean, obviously, we could put it equally well under either category. The argument we could put it under the earth science theme pretty easily, and obviously, anything in one theme will appear in the other parts of the box anywhere. But it could be this, it's a combination of improvement of algorithms, documentation of algorithms, testing of algorithms, dissemination of algorithms and data, or something of that sort that you'd have. Well, of course, John, and then the people like mine who study Unix, and there's a bunch of these things out there that do work, and then there's a large number of others that don't work, and then there's a huge amount of stuff that's floating around, which is sort of okay, but there's no one but never really been tested, and you never really run out, what parts work and what.
Who's going to do it?
What?
At what cost? I mean, it's going to cost money.
Yeah, well, I mean, if this is a theme of something one intrinsically wants to do. I mean, we're still, wrestling with GPS. You get when the rubber meets the road, it makes a difference whether you use Gammon or Gypsy. Greenland is either going up or down depending on whether you use Gammon or Gypsy. So, I mean, the question is, but these are opening them up as research topics. I mean, you can't. None of this is like an oil company where we've assigned people to tasks. This is an area where we say, look, these are things that people want. These are research areas which people are interested in pursuing. You can't make anybody do any of these things. But we're saying these are things that would be worth doing if there are researchers interested in doing it. And I was treating Ridge's implication as if there would be people interested in looking into these kinds of questions if funding were available for them.
There is an NSF program right now. It's called Software Infrastructure for Sustained Innovation. So, I mean, this is like exactly what this is for. Right?
Yeah, that's a good point. So when we are talking about here, obviously all that is important, but on the other hand, we have to maintain a focus that is right on the expansion or the continuation, whatever, of the CMG. Because if you get into the data infrastructure, there are cyber infrastructure, geoinformatics, EarthCube, and SI2. All these existing programs we just lost.
Well, let me go back to Greg's point then, because I'm going to back down now and say maybe just saying we're going to have boot camps to sort of to make sure all these people are brought up to the sort of state of the art in software. What are the existing tools? How Python, C++.
And that comes under the education theme. Then you're going to have an educational program theme that we're discussing, and that can be one of the aspects.
Right. So let me just give you an example. So one of the projects we have is called the Phoenix Project. International project. We develop tools for building simulation codes, and people contribute to it from all over the world, and people use it from all over the world. And you can go in there, and I've seen some really wild and crazy models that have been programmed in Phoenix. And so we have courses. Royal We here at Matt is giving courses, and other people. And this is an example of the kind of international effort where you don't have to write the software from scratch, and you can participate in developing high-level codes. And people contribute to it from surprising places. So I can imagine somebody who's at least had the right boot camp could actually make a contribution to that project, even if they weren't trained in computer science. So that might be a way to deal with it.
I think it would be more valuable than sending people to boot camp if you said that we will respect contributions in this area. So I'll give you two grad students. One grad student is told, give me this result about the sea level. And the other grad student is told, give me this result about the sea level, but do it in such a way that someone else can reproduce it and also get the same result about the sea level. Now, they take 2 different amounts of time, right? But if you put a premium on this one that helps everyone, this kind of Clairvaux style of development, then they'll do it. And saying that explicitly, saying that we do respect this kind of work, is what makes a difference. It does not make a difference to send someone to boot camp and then send them every kind of other signal that says this work doesn't matter for graduate.
So supporting reproducible research is a good idea, and NSF will like it as well. But that's not the category up here, though. That's a separate aspect.
I'm just saying.
Yeah. Sure, absolutely. We should be pushing everybody in that direction.
Every proposal you submit now has to have something related to this. How will you support your data? How will you keep things, sustained?
Right, but you need the same thing on the software side too, so that 2 years later you could actually reproduce the calculations in your paper, which I can't for my own papers.
One of the principles, take it one step further. I don't know this community is ready for that. So I work with quantum chemists, and there is a project called MATS, multi-resolution adaptive and so on. So basically, it got, by the way, this year prize of R&D magazine for one of the 100 projects. And so it's based at Cambridge. And essentially, if you want to do computation as a quantum chemistry, you basically can write a mathematical formula. And the adaptive algorithm that I decided will solve it. So basically, it's the first attempt to do something where accuracy is controlled, everything is controlled. So now, for geophysics, I don't know whether this whole thing is ready, but it will come to this because after all, you're working with the same object itself. So how do you utilize? There are no mothers in the sphere. Rotation in there, and there's some executable group. We basically use mathematical foundations that we build underneath all of this kind of stuff.
Maybe the way to do it, this is a good point, maybe the way to deal with this is to present it as a mathematical challenge, because many of the things we do in the Phoenix project, we present as mathematical problems. In fact, it's code automation, like you're talking about, and often this brings up interesting mathematical issues which you never would have thought about. I mean, very much discrete math problems. So maybe this could be worked into a good thing.
It will work in the very different corner, and it's not an question, because then you start talking about adaptive, building adaptive algorithms and fast algorithms. By the way, Robert Harrison was quantum chemistry, put it on 40,000 processes. So.
What is the name of the project again? Madness?
It's Robert Harrison's.
Oh, okay. Adaptivity needs to be up there after, maybe before accuracy. Accuracy, stability, scalability. Adaptivity is the most important thing to have.
Well, if you've got a time limit,
yeah.
Stability.
We call it go.
All right, well, sounds like
So is it time to mention the bar again?
it sounds like it's dinner time.
Yeah, we've got to get to work and go see that bartender.
That's right.
Okay, we're at Mount